All right, so let's continue with limit concept. Okay, so in this part, we're gonna start to get a little bit calculation involved. Okay, look at two theorems. Okay, very straightforward theorem. If you still remember from the previous lecture, I'm asking, okay, maybe let's have a little recap. Limit as x approaches 1, I'm asking, okay, what is x plus 1, right? And remember that's on our third graph. You see that limit, if you still remember, which equals to 2, right? But where is this limit from? Some of you might already discover that, well, if you substitute x with 1, 1 plus 1 gives us 2, right? So that's exactly the theorem I'm going to tell you about, which is called the limit of polynomial. Assume we have a polynomial with degree n, okay? And you can see that this is the general polynomial written format in a decreasing order. And the theorem said that if you're trying to figure out limit as x approaches c Pn of x, which is a polynomial with order n or degree n, and then that limit equals, basically it's evaluate that polynomial at x equals c. Okay, so in other words, just plug in. Let's look at it with one example here. I'm asking to figure out limit as x approaches 2, x squared plus 3x plus 1. Okay, this is a polynomial, right? Actually, it's a quadratic polynomial. So what we do is we just substitute x with 2. So we have 2 squared plus 3 times 2 plus 1, which you can calculate it, which is 11. Okay, so fairly easy, right? The other theorem is called the limit of the rational function. Okay, and it is described into this way. If we have two polynomial functions, px and qx, okay, and the function we're trying to figure out, or the problem we're trying to figure out, is to evaluate the limit as x approaches c px over qx, okay? But also, guys, you have to make sure that q of c is not 0. In other words, we're trying to get rid of the troublemaker, the case when the denominator equals 0, okay? So with that in mind, evaluate this rational function. Again, just to plug in x equals c, you got that is pc over qc, okay? So another example, as you can see that we look at limit as x approaches 2x squared plus 5x plus 9 over 2x plus 3. Both top and bottom, they are all polynomials. And as you can see that when you substitute x equals 2 to the denominator, it's not 0, so we're good. Direct plug in, you're going to have 2 squared plus 5 times 2 plus 9 over 2 times 2 plus 3. And as you can do a little bit calculation here, which gives you 23 over 7. Okay, so those are the two examples. And in fact, guys, later on, when you're trying to solve any limit problem, the first attempt is trying to plug the approaching number into the given function. If you get a result, perfect, that's gonna be the limit, okay? And but often you will see that that's not the case. And then we're gonna introduce more different techniques to attack those problems, okay? But so far, just keep in mind, you have a limited function, you have a limited problem, plug in to see what happens, okay? Now, the other side is gonna be a little bit crowded because I started to give you an idea about the limit laws, okay? And what I'll do is I'll introduce those laws, and then I'm gonna erase this side and then give you examples. Often you're gonna see that those limit laws are very easy to follow, okay? But let's look at that. Okay, here we go. A lot of stuff, right? Looks scary, but no, guys, okay. So we're gonna introduce basically 6 limit laws. And before we introduce those 6 limit laws, we have 2 big conditions. Okay, that is limit as x approaches c f of x, that limit exists, equals capital L. And limit as x approaches g of x equals capital M. Okay, so you have to make sure that those 2 limits that both exist. Then our limit law are valid. Okay, otherwise nothing can guarantee. Okay, make sure the limit of fx and the limit of gx both exist. Also, b is a real constant. And by the way, guys, so far in calculus 1, all the problems we discussed are based on the real number system. We will not talk about imaginary number system. Okay. So let's get started. So the first is called the sum of difference rule, limit laws. It says like this: if you have a limit, okay, of sum of 2 functions or difference of 2 functions, that limit equals the sum or difference of the limit of each piece. So limit as x approaches the fx plus g of x, or I should do one more parenthesis here, equals, as you can see, guys, it's kind of like the distribution law, right? So equals the limit as x approaches the f of x plus limit as x approaches g of x. And we know that each limit exists equals L and M, so it equals L plus M or L minus M, depends on the sign. Okay, so easy. In fact, guys, if you okay, I'll come back. Okay, I'll come back to give you some examples. I was planning to show you that if you still remember, we talked about the limit of polynomials, right? If you think about a limit as x approaches, well, maybe let's take a look. Okay, so if you look at this problem, guys, limit as x approaches to x squared plus 3x plus 1. If we treat this as a function, this is not a function, this is not a function, constant function here. Do you agree that we just learned the limit laws for sum or difference? So limit of this one plus this one plus this one equals the limit of x squared plus the limit of 3x plus the limit of 1, as you can tell, which is 2 squared plus 3 times 2 plus 1. Okay, so that's one of the examples. Okay, now let's move on. The other rule, which is called the constant multiple rule. Okay, what it says that is if you try to evaluate a limit and that function format is a constant times the function, and then you can always pull the constant out, and then it equals b, constant b, times the limit of function fx. That is b times capital L. Okay, so in fact, okay, so, and the third one, product rule, it said that if you have a limit as x approaches c, fx times gx, so limit of the product equals the product of the limit, which is L times F. Okay. Quotient rule, similarly. Okay, or quotient law. Okay, because later on when we talk about the derivative formula, we're gonna have a quotient rule. Okay, so let's stick with quotient law. Okay, and it says like if you have a limit as x approaches c fx over gx, then limit of the quotient equals quotient of limit. In other words, you evaluate it separately, equals L over M. Of course, we need to make sure that capital M is not 0. Okay. Number 5, power law. Okay. So if you evaluate the limit as x approaches c, f of x to the power of n, so limit of a function of a power equals the power of the limit of that function. Okay. So in other words, you can evaluate the limit of this inside function first, and then raise to the power n. And we know that that limit exists, which is capital L. So it's L to the power of n. And of course, you have to make sure that your n is a positive number. Okay. Last one, the root law. Okay. So it says like if you try to evaluate limit as x approaches c, the nth root of fx. What you can do is you can evaluate that limit first, which is limit x approaches c f of x, and then take the root, the nth root. Okay. Of course, this n should be positive, and also remember that, guys, if you have a square root, inside of the square root, it must be non-negative, right? So put a little bit more restriction is if n is even, you got to make sure that your function is non-negative, which is greater or equal than 0. So those are the 6 basic limit laws. And right now, let's play with one example. Okay. So let's see. Okay. So let's do this. Let's assume if we have a limit as x approaches 2, let's see, x squared plus 3x plus 9, right? So this is fx. Limit as x approaches 2, let's see, we have, what about negative 3x plus 2, plus 4 over, I don't know, 2x plus 5, okay? So fx is here, okay? This is our limit as x approaches to f of x, okay? Equals this. This is our limit as x approaches to gx, like this. And as we just learned that we can evaluate those two limits immediately, which you can plug in, give us is 2 squared plus 3 times 2 plus 9, right? Which gonna give you is 19. This one you're gonna have is negative 6 plus 4 over 4 plus 5, which give you is negative 2 over 9. Okay. All right. So now let's try to do something. So limit as x approaches to fx plus gx equals limit as x approaches to fx plus limit as x approaches to gx. As you can see, it's 19 minus 2 over 9, okay? Well, which is plus negative 2 over 9. And you can do plus and you can do minus, similar thing, okay? So that's the sum or minus. Let's do a constant multiple rule. What if you have something like this? Okay, let's see. If you have, let's see, negative 4 times, let's see, fx, okay, which f of x, okay? And then you can always pull this negative 4 out. Limit as x approaches to f of x. And we know that limit equals 19, right? So it's negative 4 times 19, which gives you is negative 76. Okay? Easy. Now let's do this one. 3 limit as x approaches 2. Let's see. X squared plus 3x. Oops. Let's do this. So which is, I'm trying to write into fx times g of x, which is limit as x approaches 2. Let's copy that. X squared plus 3x plus 9 times negative 3x plus 4 over 2x plus 5. Based on the multiple law, limit of the product equal the product of the limit of each. And we already know that the limit for each function, which gives us 19 negative 2 over 9. So this equals into 19 times negative 2 over 9. Okay? And then the other one is if you have a limit as x approaches 2, let's see, fx over g of x. Okay. As we talked about, limit as x approaches 2, g of x equals negative 2 over 9. So it's not 0. So this equals limit as x approaches 2 fx over limit as x approaches 2 g of x. All we need to do is to replace that 19 over negative 2 over 9, which give you, this is going to be 71 over 2, there is a negative. Okay? So that's sum, difference, constant multiple, product, quotient. Let's do power. Let's do this. 5. So let's do limit as x approaches 2. Let's do this. So let's do fx squared. Or if we write it out, okay, they're gonna give you is x squared plus 3x plus 9, then square. So the problem I give to you is it's something like this. Okay, let's put a square here. Okay. Ask you to evaluate the limit as x approaches to this something square. Based on what we learned, limit of something square equals limit of inside of that function then square, which is limit as x approaches 2, x squared plus 3x plus 9, bracket, then square. Okay? We already know this equals 19, right? So give you it's 19 squared. Okay? So I believe that's a 361. So yeah, 361. Yeah. So that's 5. Let's do number 6. Let's see. Erase these pieces, and maybe also use this one. Okay. So number 6, which is the root law. Let's see. Limit as x approaches 2. Let's do. I don't know. So let's do cubic root of negative 3x plus 4 over 2x plus 5. Okay. So basically it's limit as x approaches to cubic root of gx. Okay. As you can see, a limit of a cubic root equals the cubic root of that limit. Which this, we know that it's negative 2 over 9. So you're going to have its cubic root of negative 2 over 9. Okay? So right now we covered those 6 laws. And basically, guys, those are very, very straightforward, right? As you can tell. So take a break and then I'll come back with the last part for 2.2. There are some technical problems get involved to evaluate the limit, and then I'll talk about that soon. Okay.